Alright guys, today's video is gonna be more interesting and fun because we're just diving again more deeply in Math 1300 or Linear Algebra, because a lot of people have a lot of misconceptions when they're dealing with matrices or anything that requires linear algebra. One of the famous ones is that, did you know in matrices AB and BA are not same? Just like over here, you see how AB and BA, if you multiply them together, you will definitely get a different result. So today I'll teach you the most important matrix properties you need to know for your assignments and exams, because they are kind of basic, but you do need to know them while solving them. One of the famous one is this one, the addition property, or in other words you can call it the commutative property, which in other words is about addition. So it goes something like, if you have two matrices, let's just say you have matrix A and B. Now if you add these matrices A plus B, or you do B plus A, doesn't matter, it's gonna be the same, because unlike multiplication, the commutative property for addition is the same as in math, like 5 plus 2 or 2 plus 5. They both will give you the answer 7. The next one is kind of building upon this one, but it's slightly different. It's called associative for addition. So associative is when you have more than one addition involved. So it can be like, maybe you have three matrices that are being added, A plus B plus C. So you can either do A plus B first and then add the C, or you could just do B plus C first and then add the C. It's gonna give you the same answer anyways. Just like if you have three numbers, you can add them whatsoever in whatsoever way you want. But these things are only true when we are talking about addition. Now, another important part is when we see some scalar multiplication. So scalar multiplication, in other words, is just simply a number multiplying to a matrix. Now scalar number can be anything. Let's just say it's a small k, and now this k is going to multiply with two matrices that are being added, A plus B. Now when you're going to add it, just like in for a lot of you this is called FOIL, or you can just expand the bracket. You can just first multiply k to A and then k to B with a plus sign in between, just like in regular math. Or in other words, sometimes there could be two scalars that can be multiplied, like let's just say we have k plus m and there's a matrix A that is being multiplied to it. So in these cases it's gonna be ka plus MA. Now notice in all of these situations the order never changes. Like if A is afterwards, it comes afterwards. If A is before, it comes before. Though it's not important for additions, but in multiplication order really matters. And in other words, if you have also noticed, I put capital letters for all the matrices, while these small words are like variables, or like in other words, small letters are used for numbers. So this is another important property. Another thing is matrix multiplication. So a lot of people confuse this because they think it's just like a regular multiplication. Okay, I screwed up the spelling, but it's fine. Multiplication. Alright, yeah. So matrix multiplication is like, let's just say we have two matrices. Like I already showed you the first kind, which is like AB and BA, they're not the same. So keep that basic thing in your mind, because A multiplied by BC, you can also write it as first you multiply AB and then you multiply C. Now note, when I say this, I don't mean that you can also do AC and then multiply it with B. Why? Because this is changing the order. Like C is not being multiplied to A, it's multiplying to B. Similarly, B is multiplying to A. And A and C has no relation because they have only a relation through B. That's why this thing, it's not possible. It's a big no-no from my side. So yeah, keep these things in mind. You can also combine all the properties we have learned and sort of put it in mega form. Like if you have three matrices, like A multiplying with B plus C, then you can also say it's AB plus AC. Now in this thing, again, you cannot write BA plus CA because this is wrong. You can never change the order of a matrix. Like if A is first, it's gotta be first. Similarly, if you can also write like A plus B and then there's a C matrix multiplying to them, it's gonna be always AC plus BC, not CA, not CB. This is an important part of doing this. And it all relates to this, the very first line I showed you, that AB and BA are not the same. So never interchange their positions while solving these matrices. Keep that in mind. Okay, remembering these points forever helps you build on the other points, which are kind of general basic points but truly important. The other important one is called an identity matrix. You all know identity matrices are just like simply 1 and zeros, which are like if you have an I2, a 2 by 2 matrix, having an identity is going to be 1 0 0 1. Similarly, I3 will look something like this. Sorry, let me just increase this. It's going to be 1 1 1 0 0 0 0 0 0. This is an I3. Similarly, you can also craft I4. The beautiful part about identity is if you multiply, let me just write it down. If you multiply any matrix with an identity matrix, you get your matrix back. And it doesn't matter if it's AI or IA. It's still gonna give you the A part back. This is the part. Though it might not be useful now, but later on in a video, I'll teach you guys how to do inverses or how to do transpose. These properties are gonna be really helpful at that time. And you can also use this identity in proving a lot of stuff in matrices, which I will also probably make a video in the far in future. So this is an identity matrix. The other thing you might need to know is a zero matrix. Well, it might sound dumb, but we also have a zero matrix just by the name itself. Like it's a matrix full of zeros. So if you do addition with a zero, you'll get the same thing back. And if you do multiplication with a zero, I think you guys already know what's gonna happen. 0A or A0, it's gonna always give you a zero. So zero matrices are self-explanatory, but this is important. Now, as I mentioned about inverses, there's a really beautiful property about inverses, that if it goes like this, it's actually word to word like this. If A is invertible, like if there's a possible inverse, we're gonna talk more about inverse in the next video, then A multiply with its inverse, or you can just first do the inverse, multiply with the original matrix, you'll always get an identity matrix. Keep this point in your heads, because in the future video, the next video probably, I'll teach you what does this thing means and how do we use this thing to find an inverse of an original matrix. But until then, we are just discussing this thing. So if this helped you like notice the basic rules of matrices, because these things are quite basic, but you need to keep them in your head so you don't screw up your calculations or make some errors which will lead to losing marks. So next I'll try to cover inverses on matrices, and you will learn how to find an inverse. And yeah, if you find these basic properties easy, try solving some multiplication questions, or I will also give you some questions in the next video. But until then, today's video is all about the matrix properties. These are some basic ones. Keep them in your head and try not to forget. And I'll see you in the next one.